Streaming live via the internet. Welcome to ISP Radio, your weekly source for ISP-related news, events, and interviews with industry experts. If you deliver internet via fiber optic, wireless, coax, or any other way, you're in the right place. Chat live with us weekly via ispradio.com every Wednesday at 11 a.m. Central Time. And now a brief word from our sponsors. Link Technologies, providing ISP consulting, support, and hardware for wireless ISPs. TowerCoverage.com, providing online RF coverage maps. And now your host for ISP Radio, Steve Grabiel and Dennis Burgess.
Welcome to another edition of ISP Radio. I'm your host, Steve Grabiel, broadcasting from the office here in Moriarty, New Mexico, and Dennis Burgess is broadcasting and producing the show from St. Louis, Missouri. So, Dennis, you there?
Yep, I am here.
Any good news on the horizon? Out here, it's warming up, about 55 degrees. We got a high squatting over the state, so we're going to be warming up here. You said it's cold over there, no?
Gotcha. Yeah, it's cold here, and it's going to get colder and colder. We're supposed to have a little wintry mix on the weekend. Nothing major, nothing horrible. Heck, last year, I remember this, 2 years ago, I had moved into my new house that I live in now, and I did not have a four-wheeler or a blade to plow my road. So I'm out there shoveling a rock road. Yeah, that doesn't work so well. So at any which rate, I did that, but then last year we literally had nothing. We did not have any events in which I actually got a snow. I have my four-wheeler. Got me a snowplow for it. The whole shebang. Got it all set up. Nothing of consequence to make me put on the snow blade and go out and push snow. It kind of sucked. And this year is really shaping up to be the same thing. I mean, normally we've had a snow or two, and we've had some snow, but it's all melted, before I got to it with the snow blade. So it is what it is, We'll see how the rest of the year works, but our business is definitely picking up. Everybody gets their new budgets on the new year, and of course that always helps the grand scheme of things, if you know what I mean.
Yeah. Talking about snow, I had to go up to our tower site up on Sandia Crest, and it's a paved road going up there, but there was 3 feet of snow up there, and there were guys that came out of Albuquerque driving down, and they hadn't bladed the road yet, but there were guys in these little Honda race cars coming down and going up the mountain. I'm all, what are you doing? And they were getting stuck. I had to pull 2 people out of the road and get them going so that I could get up to the tower site to do the job. And then we had about a 300-yard hike to the tower site at 10,000 feet. Man, we were pooped.
Yeah, I bet. Well, as far as stuff coming up, everybody knows Memphis. WISP America is coming up. Memphis, Tennessee, March 14th through the 16th. Definitely really good. Everybody should go. Support WISPA by going. And, of course, that, supports all of our vendors, which I'm pretty sure it's really close to being sold out. Over 100 vendor members there. So definitely a really good time. I had to check on that. I'm not saying it is sold out, but I know it's getting close to that. So definitely, if you're going to go to a WISPA event, there you go. WISP America is definitely one to go to.
Yep. If you can get away, go to it. It's well worth the time.
Yep.
Well, let's get into our show today. Today we have from FiberPlanIt, Jonas Verstuyft, and Jonas is in Belgium talking with us, and he's the marketing manager for FiberPlanIt. I had found FiberPlanIt about a year ago, perusing the web to come up with ideas to help me design fiber optic build-outs, and I came across their website, and then just recently reached out, and Jonas responded to me and did a webinar, and I got to talking to him, and I said, hey, would you mind coming on our show, because I think this is a tool that could be widely used by WISPs getting into the fiber world. So with that, Jonas, are you there?
Yeah, hi, Stephen.
Hi. Well, thanks for being on the show. Jonas, tell us a little bit about FiberPlanIt, where it started, and where you guys plan on going, and you mentioned before the show that you guys are growing, and you've got offices not only in Belgium but in Toronto. So go ahead, take it away.
All right. So yeah, thanks for the introduction. My name is Jonas Verstuyft. I work for the company Comsoft, and Comsoft is located and started in Belgium, in the city of Ghent. And since last year, I think September, we opened up an office in Toronto, Canada, to serve the American market. We see a lot of potential in the US and Canadian market. A lot of municipalities or WISPs and engineering companies doing a lot of activity, rolling out and deploying networks. So a lot of design activity where we can assist. So FiberPlanIt is the name of our main solution. And with FiberPlanIt, we focus on FTTx network planning and design. We offer it as a software solution, but also we assist operators or consultancy companies with planning and design services. So to give you an idea and to see why FiberPlanIt exists, why we built it. We started developing it since 2008, so it's been around for quite a while. And the reason we did that is to save operators, engineering firms, consultancy firms, everybody that's doing network deployments, to allow them to save time and costs in their planning, their design, their construction phases. We want to shift the design from manual planning, doing cost estimations with Excel sheets, and doing manual planning and design. We want to shift that approach to a more automated and optimized approach. That's why we developed FiberPlanIt. For example, with one case that we did with an engineering firm in New Zealand named VisionStream, they noticed that by using our tools, they can speed up their design time by four times. So compared to manual approach drawing in CAD tools. Also, they noticed that with the tools, if they compare with their manual plan, with the plans they did manually, they see that they had 20 to 30% less trenching. So that's quite impressive, I think. So yeah, planning and design, it's a quite broad terminology. If we take a look at the workflow from or the process flow from just thinking about doing a network deployment to the actual operation of deployment, we focus on a few different stages of that process. So in the planning stages, when you're merely thinking about doing a deployment, and if you have a large area or a large region where you're active in, and you want to figure out which regions you want to target first, or just target at all, then the FiberPlanIt simulator is a solution we built for that, which allows you to easily compare different target areas to see what it would cost to build to all of those areas, and make educated decision based on that information. Now, the topic that I want to handle today in a demonstration is more the high-level design stage. So doing the initial design of your network deployment, so figuring out where you want to place cabinets, which type of cables you need to use, how to route those cables. That's what I want to cover today, and there I'll use the FiberPlanIt designer for this. Here at Comsoft, we believe, and I think that's a best practice for all network deployments, is that you closely integrate your design with a field survey, so with people on the ground that know the area and that can feed back to the people doing the design. so that you come up with a constructible and design that can actually be built. So once you have your high-level design, you have your overview for how to build your network, where to lay your cables and ducts and so on. Then you need to go into your low-level design stage, and you need to come up with your to-build plan to know exactly how to splice all the fibers together, how to splice to your splitters, and to get your complete duct layout plan, cable layout plan for the field crews. So that's something that we are able to cover with our FiberPlanIt Engineer. That's a solution that we will launch in February at the IFTTx conference in Marseille in France. But like our own other tools, it will be available worldwide. We also support integrations with other engineering and inventory solutions to speed up that process, because we notice that a lot of our customers have or already have an inventory solution or have a preferred solution that they want to use, and we want to bring the power of FiberPlanIt within those tools. Now, I don't want to keep you too long busy with a presentation, and I want to go hands-on with the solution so you can see it in action. But let me first explain a bit what I want to do in the demo. So what I want to show is how you can do an initial design with the FiberPlanIt Designer, and basically, you start off with satellite overview of your area. So you know where your buildings are located, how the streets are running, so that you know where cables and where you could do trenching. So basically, with our tool, we need a geographical representation of that information. So you locate your buildings, locate your streets, and then you need to start by defining the different routes that are available. So that's where the actual planner has an important role, where he needs to make sure that you get a constructible design, making sure that you have permits for trenching at the different locations. Now, with the initial design, what the goal is to locate your fiber concentration points, assign buildings to each fiber concentration points. So that's what's represented with these clusters here. And then in the next stage, you need to make sure that every building is connected back to the central office. So that's basically what I will show in the demonstration for a particular example. Just to give you another view on this, so basically with our tools, you start from GIS information. I'll give you a quick example in the demo how I got information for an area that Stephen suggested me to design, and then with the designer, you specify the type of architecture that you want to deploy, and it will apply the rules, taking into account cost of trenching and so forth into account. Apply those rules to the GIS data so that you get a high-level design, and then with the engineer, with integrations to other engineering or inventory solutions, you can come to a to-build plan which is ready for construction. So what I'll do is I'll get the GIS data, configure the design rules of the architecture I'm interested in, and then go through a design iteration, and show you how you can then also fine-tune that design to come up with alternative designs based on field input, and show you what the generated bill of material looks like, and show you the design details. So this is a satellite overview of the area that Stephen suggested me to look at. So first, step that I'll take is gather my input data. So I need GIS information. I'll show you something that we often do for our projects that we do in-house as well, is to extract streets from OpenStreetMap. So there's a lot of good detailed information available, which you can extract and use. And also I'll show you how to draw your endpoints quite easily in QGIS, which is the GIS tool, open source tool that we use for our design. And then I'll walk you through FiberPlanIt, and then afterwards inspect the design, inspect the bill of material that was created. So let's first take a look at OpenStreetMap. So this tool, extract.bbbike.org, it's a very interesting website where you can extract GIS information that's available on OpenStreetMap. So if we go and take a look at the area we want to design, we're here in Edgewood. So here we have the data available that we want to design. So you see we have streets available, but no building information. There are areas available on OpenStreetMap where you can also extract building information, but here unfortunately it's not the case. So we can easily indicate which area we want to use. So simply indicating this, we can extract that data like this. Extract that data and get that information within in an instance. So I did this before when I prepared this webinar, this presentation. So here I have the data in shapefile information available. So we're now in the QGIS environment, which is an open source GIS tool. So as you can see, we have road information available. So with the name of the road, some basic information. We also have some buildings which are here. But if we take a look at the Google satellite images, we see that a lot of building information is missing. So that is data that we need to add before we start doing a design. So to simply show you how this can be done in QGIS, I won't spend too much time doing this, but you can simply start adding the demand point locations of the buildings we want to serve in our design. So simply looking at the satellite images, you can start adding these points, and these can then be used for doing a design. So we have our streets. We have some locations. I prepared an area of 40 homes, which we can load into FiberPlanIt. And let me just do that here. So if I set up project for this particular area, so we're here in Edgewood. If I select the input data I prepared, I have my demand points which I quickly drew, and then I have my streets available. Okay. So this is now setting up my project. So we in a different window. This is here. Yeah. So here I added some locations and have my street information. I hope my screen is coming through all right. Can you confirm that, Steven?
Yeah, it's looking good.
Yeah.
Okay. Okay, great. Just wanted to confirm. Okay, so if we take a look, let me just show you what this looks like with Google Satellite image underneath. So I picked out small area here. Green dots indicate building entry points for these buildings where I created this information. So this is a starting point for doing a design with FiberPlanIt. I reckon that for when you do a manual design, you start off with this satellite image and start drawing how to connect all of the buildings.
That's how I did it.
That's how you did it. Okay, so the difference with doing a design with FiberPlanIt is that you need to gather some GIS information. It's an automation tool which needs to be able to read in the points it needs to connect and needs some information on where to lay the cables. So this is the basic input data that you need. So you need to know where the buildings are, need to know how many homes there are inside of a building. So here I assume that every building consists of one home. Added information to the GIS data, and now we're good to go to do a design with FiberPlanIt. What we need to do to start a design is to tell the software what the available routes are that he can take. What does that mean? We need to present the software with the possible trenching locations, but this is not the case here, possible aerial routes that he can take. Luckily, you don't need to do this manually. This is where FiberPlanIt has some automated pre-processing steps. So first step that we'll do is we'll calculate the locations of trenches. So what this does is it reads in the streets and presents you with all the possible street side trenches that can be used. Now here the planner can manipulate this information and he can indicate which sides of the road cannot be used, for example, or he can provide additional information if that's available, saying this is a dirt route, this is an asphalt, this is tiling, and assign specific costs for doing the trenching there. And these costs are then taken into account for the design. So this is the first step. Second step for an underground design is connecting my my buildings to these street side trenches. So generating the lead-ins for the buildings. So here we now have lead-ins created for each building in the area. And here again, the planner has a lot of control. So for example, if I put Google Satellite underneath here, for example, you can already start to manipulate what the final design will look like. For example, here for this building, probably the lead-in will not go like this, crossing his whole garden, but will actually follow the driveway here, the same. So here, for example, it will go like this. So you can manipulate what the design looks like and how the routes are taken. This is important as well when generating bill of material and getting accurate estimates, accurate cost figures of what it will cost to do trenching in these locations. So the designer can go around and manipulate this data to have a very accurate initial plan. Then another step that we need to take for doing the underground design is give the tool a possibility to cross a road. So this is generating possible crossing locations. And again, if, for example, in your GIS data you have loaded highway information, these are roads that you won't be able to close down and cross. So you can indicate in the data that you cannot cross these roads. No crossings will be generated. And then when the design is calculated, the software knows he cannot cross these roads and will take that into account for routing cables and ducts. So this is what a prepared area looks like. If I just save this, so after doing edits, you need to save your design, save your prepared area for the design. Then our GIS data is good to go, and the software knows exactly where he can route cables. The second aspect that's quite important is network architecture. So in our solution, you need to provide unit cost information of equipment, so the material and the labor costs of deploying equipment, deploying cables, and also all the different options. So which sort of cables that can be used and which sort of ducts can be used, and whether you will use duct or just directly bury your cables. So let me just load in the design rules that I prepared beforehand. And then I'll walk you through some of the configuration settings that I did. So Stephen, I asked you some. I wanted you to provide me some information on what your design will look like. So if I walk you through here, so we'll provide 2 fibers for each home. And we're doing point-to-point design. So each home in my area will get two fibers directly from the central office location. In FiberPlanIt, you also have the possibility to do a GPON design, indicating where you want your splitters to be located, which type of splitters you want to use. So that's also a possibility. But for this particular example, we'll do a point-to-point deployment. Then secondly, what the software needs to know is how much it will cost to do trenching. How much does it cost to do street side trenching? How much for lead-in? How much for crossing? So that he can take that into account for doing the cable routing. So that's information that's entered here. And then also some more general cost information, like the cost for closure, splice, manhole, handhole. All can be provided, can be taken into account for the design, and will be listed in the bill of material that's generated. So if we take a look at some other configuration settings, So you can indicate whether you want direct buried cables or if you want a microduct bundle or a conventional duct. So here we will use direct buried cables. We'll have more or less two layers in the network, where we have the feeder layer, which will serve a closure, and then we'll have a direct cable to the building. It's also possible to have an additional layer for the drop if you have a splice enclosure in front of the building, for example, and you have a larger cabinet. But in this case, we're looking at a quite small area of around 40 buildings. So yeah, we'll only use 2 layers in this case. So additional information that then needs to be provided is type of cables that will be used. So here we can see the drop cable to the home, which is a 2-fiber cable, which has this particular cost. And then for the feeder cables, we have 2 options: either 24-fiber cable or 72-fiber cable, with this material and labor cost information. Yeah, so in the design rules, out of the box, a lot of
Jonas, you there? We lose Jonas?
Yeah, it sounds like it. Well, if that's the worst problem we're doing pretty good.
Yeah, this looks pretty interesting to me. To see what my actual cost was versus a automated design.
Yeah, I mean, this is the the goal. I was gonna ask him some questions, but we had to get him back here. Yeah, he hopped off here. Keep in mind, Jonas is in Belgium, isn't he?
Yeah, Belgium.
Yeah.
There's a storm over the transatlantic fiber optic network, I've been told.
Fine. Well, hopefully we'll get him back here momentarily, and all will be good, if you know what I mean.
Exactly.
But since we're gonna pause here and see if we can get him back, really good information. It's really kind of neat. Is this this is a standalone software that you're purchasing?
I think it's a cloud-based idea. If you remember, I had COS on the show a while back, and they're the ones that do the planning, as in finding out where the customers are at and what they want to pay and all that stuff. Is where this is kind of the taking all that information and driving it into a design, so it's automated instead of doing it. But like I did, I just took the Google picture and dropped points along the road there and decided, okay, I'll run a 72 strand here, and then I ran the lines off of there to the house. And it's just meticulous. For a larger project I've been doing, I've been doing it this way, and I've had to have my ops manager, who's a bean counter, go through and audit the work I've done to verify that all the links that I have for the 2-strand fiber going to the people's homes is included in my my numbers. Well, lo and behold, I forgot a complete street that missed out on a lot of the 2-strand. So by automating this, not only does it speed it up, I think, but it also, because I've been working every morning for about 2 hours, like early in the morning, putting this together to go for funding, and I need to know exactly the amount of money I'm going to be needing to ask for. And by automating it, I wouldn't have missed those things that my bean counter controller, found and said, hey, you forgot this. There's 4,000 feet of 2-strand fiber that you missed. Well,
that's a big miscalculation.
At 7 cents a foot, it's not too terrible, but I mean, that's around $3,500 I think we came up with that I missed on that design. But if I were utilizing the FiberPlanIt's automation tool, I mean, there's some things in this tool that I'm seeing that, I mean, from the project that I'm currently wrapping up, that's what we're looking at. A lot of those homes are homes with aircraft hangars and homes on the same property, so they were adding a bunch of things that wouldn't necessarily have a fiber run. and a lot of the design, they're just straight lines off of the trunk. Well, I don't want to drill underneath someone's driveway when I can avoid it, so we just plowed it in on the areas that don't have nice paved driveways. That's on my personal design, and my whole point was to get Jonas on the show to tell us, how much money I would have saved using the Planet IT solution. Jonas, are you back? I believe we have Jonas back.
We think.
Yes, for some reason.
Hey, Jonas, you're back.
Yeah, sorry. Can you hear me?
Yep.
Yeah, we hear you.
Okay, sorry.
Yeah,
so my laptop just froze.
A reboot, huh?
Which is not good, so I had to reboot.
Well, we'll let you get
That's
back
right.
to where you were, and then we'll go from there.
Okay, thanks.
So we were just talking. So the software is kind of like is it a add-on for QGIS, or is it a cloud-based service?
It's so it's a desktop. It's a plugin for QGIS.
Okay. So it's a desktop app that has a plugin for QGIS.
Yeah,
gotcha.
Indeed. And then you have the toolbar, which is a plugin for QGIS, which allows you to call all the functionality from FiberPlanIt.
Gotcha. Okay.
So I was wrong.
I can say it's looking
Right.
looking really interesting.
Hello?
Yep.
Yeah, we hear you.
Okay.
We hear you and we see the screen.
Okay, great. So what was explaining is that there's a lot of configuration settings, and I configured it now as close as possible the design that Stephen provided, the architecture that we want to deploy. I don't know whether you have any questions.
Well, we were just talking about that. In my initial design, the old way of doing it, opening up Google and running your lines down and get the mathematics and all that stuff. And your design that you did for me, it's interesting in the fact, and it's totally customizable, because a bunch of those homes, they're a home and there's a home and a hangar. This happens to be an air park, so there's a home and a hangar. So you counted hangars as drop locations, which is fine. I mean, I could take those out, no problem with your software, I imagine. But it's a good representation of my time-consuming design compared to the automation that FiberPlanIt provides.
Do you have any idea how long it took you to do the design?
This particular design, not a whole lot. Maybe 2, 3, 4 hours or something like that. And this was my first fiber project. So, and I had some collaboration from other people that have been doing this kind of stuff. But yeah, I mean, in the amount of time that you put this together, I probably saved a bunch of time. And I was telling Dennis, I'm doing another larger project where I did the same way of designing, and much larger project, and doing it the rote way, I missed out on an entire street of drop lines, and it turns out it could have been, about $4,000 mistake had I not had my office manager, my bean counter, go through and count things. So your design tool, being with automation, would have caught that and saved me a pile of time. So go ahead.
Can you hear me, guys?
Yep.
I can hear you.
Okay. I prepared network architecture. I prepared the area, and yeah, the great thing about FiberPlanIt is the network design automation. So if I just calculate the network plan here, what it will do is it will read in my GIS data, read in the architecture and come up with a design for the area. So that's what's happening here, and then we'll write out the output being the JAS data and bill of material.
So this is all powered by your computer for the most part.
Yeah, so it's all running locally on my Windows machine, which apparently sometimes crashes during webinars. But yeah, this is all done locally. So this took around a minute or so.
Ah, cool.
Then showing you, and yeah, I have my suggested central office location here, but I know you have it somewhere over here, I think. So
go ahead.
yeah, so
I
just yeah, please. You can interrupt me if you have a question. I'll show this later. Just go ahead.
Anyways, my knock is over to the left of the blue. There's a rotating beacon at this air park with a high capacity microwave link that feeds the air park right where you're. Yeah, exactly.
Oh, there, right. Yeah. So good thing about this is I can force this location to the tool. If I recalculate the design, it will take into account the new location.
Ah, cool.
Reroute the cables and yeah, recalculate the bill of material. And as it's not taking too long, we can just do that here. Then let's take a look at what the software calculates, because what I did here is a high-level design. So what it does, it applies the network architecture, shows you where to do trenching, type of cables to use, type of ducts to use. Then if you want to go to low-level design and you need to know how to splice fibers together and so forth, that's the next step.
Kind of like your fiber splicing plan. I mean, it'll even spit out this color splices into this color to get to the house. Is that as detailed as this gets?
Yeah. So
wow.
that's not what we do with this tool. That's
right.
Our solution that's being launched in February, and that's an AutoCAD based solution. So this is all in QGIS. The solution for the detailed network designs, that's an AutoCAD-based solution. So we have all of the designer functionality available on the AutoCAD platform. And so you do your high-level design with the designer, and then you can transform that into a low-level design plan. And then it shows you how to connect all the fibers together, all the construction documents, you can anything you can imagine, everything you need to go out and deploy your network, all fully automated.
Wow.
And that functionality, it's also offered with other inventory solutions, like I don't know, small P&I or Bentley, so larger inventory solutions, just to streamline that process from design to operation. But let's take a look at this high-level design. So as you see, this is now my central office location, like I suggested. We have a cable running to this splice closure, and then we have cables running to my other splice closures. You can always see the size of the cable, so that's information that's available. See, it's an underground cable. Also, for each splice closure, you see how many fibers are coming in, how many fibers are coming out. also the home count, so 8 homes per closure here. We configured that you can have 16 fibers per closure. So as each home is having 2 fibers, this is the way that the software clusters the homes together to have a maximum of 16 fibers. But as a planner, you're free to adjust this plan however you want. For example, here it only provides a closure for these 2 homes, but if you know that this closure has spare capacity to add these two buildings as well, you can use the same. You can do the same actions like I did with the central office. So you can adjust the clusters that are assigned that are associated with the closures, include them in another include these 2 homes inside of this cluster, and after recalculating, the buildings are now will be connected to this closure. So the design that comes out of FiberPlanIt, it's your initial design, it's a suggestion. You are able to manipulate it as much as you want after this calculation. And as you saw, calculation can go quite fast. So yeah, you can easily manipulate and come up with a new design. Yeah.
So before you move the head end over to the left there, it kind of showed the design as how I did it beforehand. You know, running it down that main street, the 72 strands. So by moving it over there, it took into account all the homes and it optimized, because it totally changed the route, and it optimized it for cost and for cost of materials and cost of trenching and all that stuff. Is that what you're telling me?
Yeah. So by moving that location, so it's a bottom-up calculation. So from the homes to the central office, and by clustering the homes, you create how to say it, like free routes for the feeder routing. So if I switch this off, you will see it quite clearly. These are routes that are used for the distribution layer, so for connecting the buildings back to the splice enclosure. Now, if the software needs to calculate the route for the feeder cables, these are all routes where you will have to do trenching, so no new trenching is needed there. And this stretch here would be a whole would be all new trenching. So it's much more efficient to run it over these distribution cables where you will have to do trenching already instead of running it
where your paying customers live. Yeah, perfect.
Yeah.
Well, I think he's saying that in this particular case, you're going to have a trench open, so you want to layer your feeder cable in that instead of trenching where you're not going to have any customers.
Exactly. Yeah.
It's taking into account the trenching costs that we configured and also the costs for laying the cables. So a large detour can, depending on the cost of the cables, a large detour can be more expensive, of course, than doing a whole set of new trenches. So it takes all of that information into account to decide how to route cables.
Wow.
So that's how we come up with this design. And so with the design, the software always generates the bill of material. So you can see quite detailed how much trenching will be needed and what the cost is for this trenching. See how many homes we activated, the trenching for the customer lead-ins, all the cables, all the splices, handholds, all of that information is available in the bill of material. using the unit cost information that we configured.
Huh. That is very cool.
So yeah, I can imagine that. Yeah, for a manual design, I don't do any manual designs myself, but can imagine that takes quite some time to come up with this amount of detail for your plan. And I think one of the main advantages is that you can experiment with different type of architectures to compare the different costs, and you have full control over what the final design looks like. So like I said, while preparing the area, you can indicate which routes are unavailable. So if there are certain streets which you cannot cross, or trenches which you cannot use, then the user can manipulate that information to be taken into account for the design.
Yeah, so you can sit there and say, oh, they have a concrete driveway, so you want to ensure that you don't have to plow underneath it or drill underneath it. And that, of course, could change the side your feeder cables are going to be on.
Yeah.
Depending on that. Because I mean,
it'll include it and recalculate it for those.
Right,
special,
right. It's really a matter of more data you put into it, the better you are.
Yeah, indeed. So, for example, if we look at the prepared area and the GIS data here, if I look at this particular side of the road here, you can indicate a subtype. So you can indicate whether it's dirt road or whether it's asphalt. That subtype can be associated in the design rules with a certain cost, and that cost is then taken into account for the calculation.
Wow, and when you moved the head end to where you did, that was lickety split, and the design came back just like that. This is what the change did.
Mm-hmm. Mm-hmm. Yeah. So I mean, it's also quite scalable. So depending on the architecture that you configure and the size of the area, most areas of around I don't know 10,000 buildings. So a calculation for that amount of buildings takes somewhat around an hour maybe, or half an hour to an hour, depending on the architecture that you define and the amount of routes which are available. But yeah, you can it's manageable to calculate it from your own computer.
Right. I imagine that bigger project that I did that took me so long, I talked about while you were rebooting your computer, would have been reduced to pretty quick, number one, and number two, less errors.
Yeah, that's also the one of the benefits, and let me switch back to my presentation where I have it listed. What the benefits are of using FiberPlanIt for your designs is deployment costs will go down. We have optimization algorithms, like I said, for routing the cables. But also your designs will be uniform. So imagine that you have a whole planning team spread across different offices maybe, and you have a set of design rules or network architecture that needs to be followed. With our tool, you can configure the design rules and you make sure that all of the designs are uniform. That makes it so much easier for the field crew to deploy the network. So we'll introduce savings there. As you saw, it's an automated solution, so it goes a lot faster than manual planning. So you design much more efficiently, and you still have full control. So what we did is move the head end. So these kind of tweaks and changes are available to the planner. So he can still make decisions, take into account information from the field to make changes to the design, and still keep that level of optimization. So that cable route that moved from the main street to a different street, that's a perfect example.
Yeah.
Where you take into account information from the field, put it into the tool, and re-optimize your design.
One of the things when I first saw your product a year or more ago is you mentioned that, you know, you get a group of engineers in a room and they all come up with their own design, and each one of them may be or is probably good. I mean, it'll work, but it's not optimized for the space you're dealing with. That's what I was impressed with when I saw this product.
Yeah, so what we often see is that larger operators, they have a set of design guidelines which can be 100, 150 pages long. And then it's up to the designer to interpret those guidelines and apply it to the area that they are assigned to do. And there will always be room for interpretation. And they need to make a decision on the spot on how they will plan according to that set of rules. And this is something that we want to cover with our solution, is to make sure that you don't have to worry about the design guidelines. They will be followed with our tool. So the designs will be uniform and compliant with the network architecture, and you can focus on taking into account that field data, make it add information on the field. Like you said, if you the more information you add, the better your design will be. So you can focus your time inputting that information and then tweaking the design to make it constructible, and the rest is taken care of by the tool.
Yeah. So we've heard that it's a desktop application that uses GIS information. Do you want to get into what the costs of this product are?
Mm-hmm. Yeah, it's a question we get that I always get asked. Our license, we have different types of license models, and they're they are based on the amount of users working with the software and the amount of demand points, so points that I created that you want to plan. Our starting offer for the solution as the benefit of the solution only comes when you design larger areas. So the starting point for the solution is an area license of 1,500 buildings, so 1,500 buildings, which can be spread out over multiple projects that you're doing, and that will cost $3,000.
Okay.
So affordable.
I think if you take into account the benefits so the time that you'll be able to save if you're planning to do one area of 1,500 buildings, or maybe multiple areas adding up to 1,500 buildings, I think it's quite affordable.
Gotcha.
That does sound very reasonable. $2 per sub up to 1,500, and the time savings and the money savings in the design is pretty substantial. Go ahead, Dennis.
So we had one question. Can you handle overhead and trenching on the same design?
Mm-hmm. Yeah. So I didn't cover that in this this particular design, but if we take a look back at the GIS data that you can load into the tool, you see that. So the basic information, demand points, also buildings, streets. So the streets are used for underground deployments, but you can also load in pole information or existing pipes, existing access structures. Those can all be loaded into the solution and can then be used to come up with the network plan. In the design rules, the planner needs to specify how much it costs to use a pole, how much it costs to use an aerial connection. So let me just show that here. And that information is again taken into account to determine the routing. So in general, aerial deployments are cheaper than doing trenching. So as you can see here in the configuration, we assume that labor cost for aerial connection is 3 cents per feet. So that information is taken into account to determine the routing, together again with the cost of cabling. So you specify different costs maybe for an underground cable and an aerial cable. And you also have the possibility to indicate per layer of the network whether you want to use aerial deployment or not. So it can be, as I can imagine, for security reasons or for safety reasons, you don't want your feeder cable to be overhead, but you want that feeder cable to be underground for having extra reliability, that if it's that it doesn't go into snap so easily and leave out a connection for a lot of homes. So you want to place that underground. That's a configuration that you can do in the software. Just not allow aerial deployment for one particular layer of the network.
Gotcha. We got 2 more questions, but before we get to those, I would love to get your contact information and how people can go ahead and contact you about the product.
So let me go to the end of my presentation. So they can reach out to me via my email address, which is badly styled here, I see. So that's Jonas.Verstuyft, that's UYFT, at FiberPlanIt.com or at comsoft.com. So they can
there you
choose.
go. So the next question is the 1,500 homes, is that a one-time cost or is that a ongoing cost? The 3,000?
No, that's a one-time cost. So the principle is that, and an important note to make is that it's 1,500 buildings. So if you have multi-dwelling units in your design, those are also covered with one point. So that only counts for one building. And it's a one-time cost where you get a license to do that particular area, and then recalculate, reiterate as much as you want on that particular area where you have a license for.
Gotcha. And then the last question we have is, can we specify a trenching path that is not on a street? So an alley, a backyard, something like that. My assumption is yes, you just had to define it.
Yeah, indeed. So in the tool you can so the tool generates trenches from the streets, but you can add additional trenches or also load them in immediately in the tool. So not just load the streets, but immediately load possible trenches that can be used.
Gotcha. So I guess let me ask this question. When we look at this particular map, let's say I have this particular map, and this map has 64 nodes on it, and my license is for 1,500. I should be fine with that license. Let's say I have another area that is not going to be included in this one. Is that area considered those points? Is that considered the 1,500, or is it 1,500 in one map?
No. The way you need to look at it is that you have like a credit pool of 1,500 buildings, and each time you move to a new area, so for this area, 64 credits would be subtracted from my credit pool. And if I move to another area where I'll do the design for, let's say, 150 buildings, then those 150 credits will be subtracted from my pool of credits.
Gotcha.
So you can move to many different areas until you reach the end of your pool, and then you can
and then you have to buy
additional.
You have to buy additional. Okay, awesome. Yep. Well, Steve, I think we are all set here.
Yeah, what a great show and a great product out there, guys.
Yeah, I think we're really good on the product and the show. Steve, I guess you want to wrap us up?
Yeah, sure. Thanks again to Jonas for coming on the show. An outstanding product. There's his contact information. Reach out to him if you guys are designing something. At $2 a sub for 1,500 homes, sounds like a really good deal. Jonas, you got anything else you'd like to add?
No. So yeah, I hope you enjoyed the show. Sorry for the hiccup with my computer crashing, but other than that, I hope you enjoyed and liked what you see and see the value of automated planning and our solution.
Absolutely. All right, Dennis. Well, let's wrap it up, and we'll talk to you guys, I believe, next week.
All righty. Thanks a lot, everybody. Everybody have a great week.
Thank you for listening to ISP Radio. We hope you've gained new insights and additional wisdom in our industry as well as your business. Please remember to visit our show sponsors via the links on ispradio.com. If you're interested in becoming a show sponsor, contact us at sales@ispradio.com. Now go out there and push those packets as fast as you can. Good luck and Godspeed.